Hello. I have mentioned maps before, so let me just give a bunch of examples of things that aren't maps. And so to clarify, to recall, what I mean by map is some equation of x and y that can be written in the shape y equals f of x. So something that goes from left to right, right? A map is something such that if I give it all the things on the left, so if I give it x's, then it gives me y's. So let's start with this sort of simplest example. This one. Multiplication by 3, if I give it an input, then it gives me the output. Interestingly enough, it's also a map the other way around, right? Because this is the same as, dividing by 3. And so it's a map. Here's something that is a map. That's the multiplication by 0, right? It says x equals, we don't care, y equals 0. This is multiplication by 0, and it's a map. It always gives me a y. In fact, this on its own is a map. It's, f of x with no variables. That works. That's a map. Here's another map, right? Given x and y, I always have an x plus y is always, well defined. And here is something that is not a map. It's not a map because if I give it, that's not a map. If I give it, maybe I should do 2 columns. Let's do columns. That's map, not map. That's something that's not a map because if I give it x, say if I say x equals 1, then there's a bunch of choices I could, of things that work on the right, right? It could be 0 and 1. It could also be 1 and 0. It could be a half, etc., etc. So it's not a map. Here is something that is a map. This, given x, the output is x and x. Map, easy. Here's something that is not a map for a more interesting reason, a more sort of subtle reason. This is, x equals y equals z. And, if I give you x and y that work, so if I give you, 2 and 2, there definitely is only one solution. But if I give you 2 and 3, then you don't, there's no valid nothing that matches because the equation forces those things to be equal. So there's no z that can make the equation 2 equals 3 equals z valid. So for some inputs, I don't have an output. If you want to sort of think in this way, it's a partial map. It's sort of not defined for all inputs, so it's not a map. Here's a thing that is not a map for a similar reason, right? This is x equals 0. So for some inputs are invalid, so it's not a map. Here's something that is a map. This simply says discard the input and no output. So those two are sort of like edge cases because they have sort of no input or no output, but that's valid. If you get precise with what maps means, then this is definitely one. And this is definitely not a map because it has no inputs, but definitely has no defined output, right? So 3 is a valid output, so is 2, etc. A map. You'll notice the very clean symmetry here. That's the 4 of the generators in one direction, 4 of the generators in the other direction. And in fact, visually, we can a lot of the time see when a thing is a map because it will be made of all of these and some numbers. Because indeed, I forgot to mention, but if f is a map and g is a map, then you can plug them together and do a map. So a general sort of example of thing that is a map, I'm just going to improvise here. I just put one of these here, maybe one of these here, then a 3, then a 0, and then some other copy here. That's a map. Why is it a map? Because it's made of things. All of the things inside are maps. And, you know, things that as soon as you include one of these, then you're not a map anymore. So I don't know if I could do an example. You know, you think you've got a map, it looks like a map, and oh no, because of this one, then not all inputs are valid. There's some sort of constraint on inputs, so it's not a map. What else? We could go beyond the linear things. Oh, yeah, there's one more. If we go to affine things, this one is map. This is the equation x equals 1. And for the same reason that the 0 is a map, then this one is a map as well. And for the same reason that the sort of 0 the other way is not a map, this is not a map. Because it forces an input to be a certain value. Here is the bigger than is definitely not a map, right? That's A bigger than B. Definitely not a map, because you know, for A equals 3, there's tons of B's that are smaller than 3. Note interestingly that it is possible to combine things that are not maps and get a map in the end. For example, this is not a map, and this is not a map, but together we have this, which says that this is, you know, A equals B, that's A equals B plus B. So that's A equals 2B, right? So it's the same as this one. And that is definitely a map. So this one is a map. In fact, I'm going to write it here. This one is a map, even though it's made of two things that are not maps. So it's not always easy to see if a thing is a map. In fact, unless you actually try to plug things in or to sort of reduce it to a simpler form, you can't really tell. And same, wait, no, it doesn't work the other way around. If I take two things that are maps, I get a map. If I take two things that are not map, I could or could not get a map. Depends. What else do we need? Okay, I'm running out of space. Let's cheat. There's one more thing I mention occasionally. Multiplication is a map, right? That's a map. That's not a map. It's the other way around. Oh, here's the thing that is a map. In a funny way, this one is a map. Why? Because this is A, B, C. This is B plus C equals A. So it's also C equals A minus B. And definitely for any A and B, I have one and only one valid C. So that's a map. Interestingly enough, you could almost do the same for multiplication, right? So that's A, B, C. That's BC equals A, which is the same as C equals A over B. Well, except if B equals 0, right? It's almost that, but actually, if I set 0 here and say 1 here, then there is no C. Wait, no, that gives me, if I set, wait, that's valid. What did I mean? No, if I said 0 here and 0 here. Well, I mean, first thing is that 0 here, 0 here, then that means, you know, that's C times 0 equals 0, which is always true. So that's valid for all C's, right? If I plug two zeros in here. So this is not a map because for some inputs, I have multiple outputs. So that's not a map. I should have put it in this code. Even though it kind of almost resembles that one, it doesn't quite. It's not defined everywhere in a good way. Apart from zeros, like if we ignored zeros, this would be a neat map. It's the division. It's like A over B. What other things do we have? I think I've covered all the basic generators, and then you can sort of make weird combos. I don't know what would be informative here. Can we? There's a question if can there be a useful map with bigger than actually if we allow union, I don't mention it often, but if you have some equation sometimes I use this U means the sort of union of two. It means an OR. That denotes the equation, A is true or B is true of A and B. And if I do this, then there's one thing that is a map that really doesn't look like it should be a map. And it's this one. This one, I think. What is this? In what way is this a map? A, B, C, A, B, C. It is a map in the following sense. This is A smaller than B and C is B, or A bigger than B and C is A, which you might recognize as the max function. That's the same as saying that C is the maximum of A and B. And that's very well defined. You can take any A and B and you get some C, and then you get exactly one C, which is whichever is bigger. Unless they're equal, in which case it just is equal to all three. They're all three equal. So that completely works. So that is a valid map. Even though it's made up of tons of weird things that don't look like, that are not maps. So this one is max. Two inputs, one output. Is this one a map? I don't even know if this one is a map, like on its own. That's funky. Okay, so first question. That's okay. What is this? A smaller than B. Oops. And C equals B. So clearly, clearly that's not a map, because if I say 0 here and like -1, then that's just, there's no C that works. So this is not a map. Interesting. That's a good counterexample. Here's an example of a thing that is not a map. But no one expected that to be a map, I don't think. That one's too weird. But this one works, and it's pretty funky. Here we go. I think that's all the examples I had in my head and counterexamples of things that aren't maps. Thank you for watching.